This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Algebra 1A, and Learning Target number 5. I can find the slope given a graph of a linear equation. So linear functions have a constant rate of change. That's why you see for each value of x, the value of y changes at the same rate, leading to a straight line on the graph. The slope of the line is how much it is changing up or down as x increases. It's the change in y over the change in x. It's the rise over the run. There's lots of ways people explain this. It's also the directions you need to go to get from one point to another point on the graph. So let me write something out here. Slope is going to be the change in y. That's how much you go up or down. Up is positive and down is negative. Over, as a ratio, which we'll express as a fraction, how much you need to go forwards or backwards. Forwards positive, backwards left negative, in order to get from one point to the next point. So you may notice here that 2 points have already been selected on the graph for you. Really, you can choose any 2 points. Like I could choose this point right here or this one down here, or, way off what this graph shows. The coordinate plane really goes to infinity in both directions. So, or you can just pick the 2 that have been pre-chosen for you, and you just want directions for how to get from one point to the next. And it doesn't actually matter either which point you choose first. So let's try this. We're going to see how much you have to go up or down and how much you have to go right or left to get from this point to the next point. All right, so I'm going to draw my fraction bar here to represent my ratio. How much do I need to go up or down to get to this point? Well, I need to go up, and I'm going to go up 1, 2, 3, 4, 5, 6. Now I'm in line, so I have to go up 6. Now from here, let's see how much we have to go right or left. I need to go right. That's forward. That's positive 1, 2. Positive 2. Now, technically, that is your slope, and that is a legitimate answer. Some people like to consider this as a fraction that you can reduce. Both 6 and 2 are divisible by 2. So if you divide top and bottom by 2, you could also express this as positive 3 over positive 1. What that means, and you don't have to put the plus signs if you don't want to. And what that basically means is you could also go up 3 and over 1 to get on the line. Let's see how that happens. 1, 2, 3, and forward 1. Oh yeah, look, I'm on the line. From here, you could go up 3, 1, 2, 3, and over 1. I know it's off the graph here, but that would also be in line. And you can also go backwards. You could go down 3 and backwards 1, and you're still on the line from here to here. Go up 3 and forward 1. So you can just express this also as positive 3 over positive 1, or considering it like a whole number, because anything divided by 1 is just 1, you could express this as 3 as well. To me, any of these representations are perfectly valid. So now let's try this one. In this case, the line is trending downwards instead of trending up. So instead of having an overall positive slope, this one's going to have a negative slope. So to get from, I'll choose this point. I usually choose the one from left to right. I'm just so used to reading that way, from left to right, from left to right. So I'll do that here as well. So how far do I need to go up or down to get from this point to the next point over here? All right, so here's my fraction bar. In this case, how far do I need to go up or down? I need to go down. Let's see, 1, 2, 1, 2, 3. I have to go down 3 to get in line with this. All right, so that's negative 3 since I went down 3. And I need to go forward 1, 2, 3, 4, 5. I have to go forwards 5 to get from one point to the other. Negative 3/5 as a fraction is not reducible. That's in its lowest term, so you can leave it just like this. And just to show you, it doesn't matter which point you start with. Let's start with here and see how much we have to go up or down, left or right to get to this point up here. So let's see, to start, I have to instead go up 3. 1, 2, 3. That's plus 3. And then I need to go backwards. 1, 2, 3, 4, 5. I have to go backwards 5. So these are essentially equivalent as long as you're actually going either down or backwards for one of those steps. You can get from one point to the other, and you can do the same thing to get to any other point on here. So essentially, if you want, you can just put the negative out in front to indicate that either of those numbers could be the either backwards or down 3/5. So this is going to have a slope technically of negative 3/5, although this is also correct and this is also correct. This one's going to have the slope of positive 3, although this is correct and this is correct as well. I think it's easier to just leave it the way that you originally counted because that's also correct and leaves less room for error if you're trying to simplify.